It's 3:14 a.m. Your eyes open. The room is dark. The house is silent. Your body is exhausted and your brain is wide awake, already running through the thing you said at work 3 weeks ago, the bill you forgot, the conversation you've been avoiding. You didn't set an alarm. Nobody called. Nothing happened. So why are you awake? Most people assume it's stress, and they're partially right, but stress is only one piece of a much stranger answer. Because what's actually happening at 3 a.m. inside your body is one of the more bizarre collision points between ancient biology and modern life. And once you understand it, you'll never look at that glowing clock the same way again. Let's start with the structure of a night. Your sleep is not one long continuous state. It's a series of cycles, each running about 90 minutes, cycling between light sleep, deep sleep, and REM, the stage where your brain becomes almost as active as it is when you're fully awake. You run through roughly 4 or 5 of these cycles per night. Here's what nobody tells you. Those cycles are not evenly distributed. In the first half of the night, your sleep is dominated by deep, slow wave sleep. Your body is doing repair work. Growth hormone is released, tissue heals, the brain clears out metabolic waste that accumulates during waking hours. This is the heavy, dreamless sleep that makes you feel genuinely restored. But by the second half of the night, around 2 a.m. to 4 a.m., the balance shifts. Deep sleep nearly disappears. Your cycles become almost entirely REM. Your brain gets lighter, faster, more reactive. You are biologically closer to being awake at 3 a.m. than you are to being in the deep sleep you had at midnight. That's the first reason you wake up. The architecture of the night itself creates a window of vulnerability right there in the middle. You're not malfunctioning. You're just at the thinnest point in your sleep, but then something else kicks in. Around 2 to 3 a.m., your body starts producing cortisol. Cortisol is usually called the stress hormone, which makes it sound like a villain. It's not. It's an alertness hormone. It's what your body uses to prepare you for the demands of waking life. It raises your heart rate slightly, increases blood sugar, sharpens focus. Under normal conditions, cortisol rises gradually through the early morning hours, peaks about 30 minutes after you wake up, and then slowly declines across the day. The problem is that this process starts at 3 a.m. whether you plan to wake up or not. A study tracking over 1,200 adults found that 68% of them consistently woke between 2:30 and 4 a.m., with 3 a.m. as the median time. Researchers found those early wakers had significantly elevated cortisol profiles compared to people who slept through. Not because something was wrong with them, but because their cortisol curve was simply starting earlier or climbing more steeply than it should. In people under chronic stress, the cortisol rise doesn't creep, it surges. And a cortisol surge at 3 a.m. feels like someone flicking a switch inside your chest. By the way, if this is the kind of thing you think about at 3 a.m., you might as well subscribe. It's free, it takes 2 seconds, and it'll give you something better to obsess over next time you can't sleep. So, you're awake. Your brain is in a light, reactive state. Cortisol is rising. Your prefrontal cortex, the part of your brain responsible for rational thought, perspective, and the ability to tell yourself this isn't actually a big deal, is still half offline. And into that gap walks every thought you've been too busy to deal with during the day. This is not accidental. During daylight hours, your brain is constantly flooded with incoming information. Other people, tasks, screens, noise. All of that external stimulation competes with internal thought for your attention, and the external almost always wins. The worries are there, but they stay manageable because they never get your full focus. At 3 a.m., the competition disappears. The room is dark. The world is silent. Your cortisol is rising. Your rational brain is running at half speed. And the thoughts that were waiting patiently in the background are now the loudest thing in the room. Psychologists call what happens next rumination. Repetitive, circular thinking that feels productive but isn't. Your brain locks onto a problem, a relationship, a mistake, a fear about the future, and runs it on a loop, each pass feeling slightly more urgent than the last, none of them arriving at a solution. Research consistently shows that rumination doesn't solve problems. It amplifies them, it makes abstract fears feel concrete and immediate, it makes solvable things feel unsolvable. It's your brain trying to use a daytime tool in a nighttime environment and getting completely the wrong result. But here's the part that goes deeper than stress. There's an evolutionary argument for why 3 a.m. is specifically when this happens. Your ancestors did not sleep in a lit, temperature-controlled room behind a locked door. They slept in open environments, in small groups, in darkness that was genuinely dangerous. Predators were most active at night. Rival groups moved at night. The fire needed to stay lit. For most of human evolutionary history, sleeping through the night completely and deeply would have been a liability. The individuals who woke periodically, scan the environment, assess the situation, and then return to sleep were more likely to survive. Their nervous systems were tuned to create a natural window of alertness in the middle of the night, not as a flaw, but as a feature. That window, built over hundreds of thousands of years, is still running inside you. It just has no predators to scan for anymore. So instead, it scans your inbox, your bank account, the conversation from last Tuesday that you can't quite let go of. Your brain isn't broken at 3 a.m. It's doing exactly what it was designed to do. It's just pointing that machinery at the wrong targets. There's also a chemical dimension that almost nobody talks about. Your blood sugar drops during the night. This is normal. You haven't eaten in hours and your body is still metabolizing. But when glucose drops low enough, your body responds by releasing a combination of cortisol, adrenaline, and glucagon to stabilize it. That release is sometimes enough to pull you out of sleep entirely. This is called the Somogyi effect, and it doesn't require diabetes or any metabolic disorder to happen. It happens to completely healthy people who ate a high-sugar meal late at night, or who haven't eaten enough before bed, or who simply have a metabolism that runs a little hotter during sleep. The blood sugar drops, the hormones spike, and the body, interpreting the chemical signature of a stress response, promotes you from REM to full wakefulness without asking your permission. There's one more layer, and it connects back to something older than any of us. For most of human history, people didn't sleep in a single unbroken block. They slept in two phases: first sleep, then a period of wakefulness lasting 1 to 2 hours, then second sleep until dawn. This wasn't insomnia. It was the default human sleep architecture, documented in centuries of historical records and confirmed by a 1992 sleep experiment at the National Institute of Mental Health, where participants kept in extended darkness spontaneously returned to this biphasic pattern without being told to. During that middle of the night window, people were calm, reflective. Their brains were producing elevated levels of prolactin, the same hormone released during meditation. They lay in the dark and thought about their lives. Then electric light eliminated the night. The two-phase pattern collapsed into one. The window of natural nighttime wakefulness didn't disappear. It just stopped being culturally legible. It became something to be frightened of. A symptom, an interruption. What millions of people are now medicating and pathologizing may, in part, be their body running a program that is 300,000 years old. That doesn't mean 3 a.m. is pleasant. It isn't. It's disorienting and exhausting, and the thoughts that arrive there are almost always worse than they deserve to be. But understanding what's actually happening changes the experience. You are not uniquely broken. You are not the only person lying in the dark cataloging everything that has gone wrong or might go wrong or could theoretically go wrong in a scenario you've never encountered. You are running ancient hardware in a modern environment. The cortisol is doing its job. The sleep architecture is doing what it was designed to do. The thoughts feel overwhelming because your prefrontal cortex is running at reduced capacity and there is no competing stimulation to dilute them. And somewhere underneath it all, a nervous system shaped over hundreds of thousands of years is still listening for sounds in the dark. The lights are on, the doors are locked, the predators are not coming, but the 3 a.m. wake up is. And now you know exactly why. If this video made you feel slightly better about lying awake at 3 a.m. or slightly more anxious, which is also valid, drop a comment below. Tell me what your brain goes to at 3 a.m. Like the video, share it with someone who needs it, and subscribe if you haven't. Your cortisol will spike either way.